Good day! This is Teacher Rowan. I'll be your guide in exploring Google Apps for education, for teaching and learning. In Google for Education, teachers can connect and collaborate easily while staying on task. It gives teachers the freedom to spend more time personalizing the learning experience and less time managing it. Students can learn essential skills such as 21st century problem solving, which they can use it in their future careers. As such, the accessibility features will also help and assist every learner to do their best work. Google offers different useful applications that we can use to connect education to technology. This will help our teachers as a 21st century educators to innovate and find ways on how to make teaching and learning more exciting, engaging, effective, and flexible to the demands of the society. Let's re-explore the education experience by discovering new angles to create, collaborate, and communicate as one. Para sa bata, para sa bayan, at para sa guro. Ang pagkatuto, huwag gawing komplikado. Sulong edukalidad.
Magandang araw, Sir Wilbur po, at your service. Narito ang ETUlay upang gabayan ka sa inyong pag-aaral upang lubos na maunawaan ang iba't ibang paksa o subject. Ang ETUlay ay isang free online tutorial class na pinangungunahan ng ICT's Educational Technology Unit sa pamumuno ni Undersecretary Elaine Del P. Pascua. Ang programang ito ay hindi lamang para sa mga bata, kundi ito rin ay magsisilbing gabay sa mga magulang at mga guro kung paano nila ituturo o gagabayan sa bawat asignatura ang kanilang mga anak o mga estudyante. Sa kasalukuyan, ang self-learning module mula sa rehiyon ng Calabarzon at kilala sa tawag na pivot ang ginagamit sa ating ETUlay online class. Kaya ano pang hinihintay ninyo? Ihanda na ang inyong mga ballpen o lapis, papel o kwaderno at samahan kaming itulay ang pagkatuto para sa bawat batang Pilipino. Sama-sama tayong magtutulungan para malampasan ang mga hamon sa panahong ito. Halina't matuto kasama ang inyong online tutor sa oras na ito.
Ayan, magandang hapon po uli sa ating lahat. At bago po tayo magsimula sa ating ETUlay online tutorial ngayong hapon, ay manalangin po muna tayo. Panginoon namin Diyos, maraming salamat po sa araw na ito. Pinupuri at pinasasalamatan ka po namin sa pagbibigay ng pagkakataon na kahit po may pandemic kaming nararanasan ngayon, ay meron pa rin paraan kayong ibinigay para matuto ang aming mga estudyante. Hinihiling po namin ang inyong gabay at presensya sa pangalan ni Jesus na aming tagapagligtas. Amen. So ayan, again, maraming salamat po ulit sa ating sa pamunuan ng Department of Education, sa Educational Technology Unit, para sa another ETUlay online tutorial na nakakatulong sa ating mga mag-aaral na kahit meron tayong distance learning ay may paraan pa rin para matuto. So maraming din pong salamat sa Department of Education, Schools Division Office of Pasig City dahil ngayong araw ang gagamitin po natin ay module ng DepEd Pasig City. Maraming salamat din po sa sumulat ng module, si Sir Rafi Maga ng Eusebio High School at si Ma'am Annie Ascotcha ng Pasig City Science High School. So, bati po muna tayo sa ating early birds. Si Ma'am Louie Cruz Bulura ng Buting Senior High School. Maraming salamat po sa suporta ng aking mahal na paaralan sa Buting Senior High School. So, thank you rin kay Sir Romel Abalyan ng San Lorenzo Ruiz Senior High School ang may pakana nitong basic calculus na online tutorial. Kaya po nandito ay dahil sa recommendation ni Sir Romel. So maraming salamat po. Kay Vince Luna, ang aking estudyante, maraming salamat no, na nandito ka na sa ating session. So mag-comment lamang po at babanggitin natin po kung may time pa po mamaya ang ating mga viewers. So dahil limited lang po ang time natin, ay magsimula na po tayo. So ngayon po ay nasa ikalimang linggo na po tayo ng quarter 3 ng basic calculus. So tututukan natin ang differentiation rules ngayong araw. So ang ating expectations, so in this particular learning episode, our students are expected to, number 1, determine the relationship between differentiability and continuity of a function, and second, apply the differentiation rules in computing the derivative of an algebraic, exponential, logarithmic, trigonometric functions, and of course, inverse trigonometric functions. Ayan, laser. So, before we proceed to our lesson for today, let's have first our recap. So, nung nakaraang Biyernes po ay diniscuss natin ang introduction to derivative. So, let us review kung ano man po yung mga formulas na ating na-discuss nung nakaraan. So, we have the tangent line to the graph of f at the point P with coordinates x sub 0, f of x sub 0. This is the line through P. Sabi natin that the tangent line, yun po yun. Through P, point P, having the slope m sub 1, and the slope m sub 1 is given by the formula m sub 1 equals the limit of f of x sub 0, nawala po yung f dito. We have f of x sub 0 plus delta x minus f of x sub 0 all over delta x as delta x approaches 0. And of course, ito po ay tama if provided that the limit exists. Okay? And sabi po, dinerive po natin ito noong nakaraang Friday na galing sa formula ng formula ng slope ng isang secant line sa curve. So the derivative of a function y equals f of x at x equals x sub 0 tells us that f prime of x sub 0, the derivative at x sub 0, is the slope of the tangent line to the graph of the function at point P with coordinates x sub 0, P of x sub 0. So ang ating formula ay limit of f of x sub 0 plus delta x minus f of x sub 0 all over delta x as delta x approaches 0 provided that the limit exists. So diniscuss din natin ito, no? The derivative of a function f of x denoted f prime of x at any x in the domain of the given function is defined as, so ito po yung definition ng derivative of a function, the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0, provided that the limit exists. So meron din po tayong diniscuss na alternate equation of derivative by setting x equals x sub 0 plus delta x. Ito po yung kinuha natin yung derivative ng function at a specific point. Let's say that point is x sub 0. So the derivative of f of x at x sub 0 is equal to the limit of f of x minus f of x sub 0 over x minus x sub 0 as x approaches x sub 0, provided that the limit exists. So I hope ay nakapag-recall tayo ng mga formulas natin na yan dahil titingnan natin kung anong relation nitong mga ito sa ating lesson for today. So let's proceed to our lesson for today. A function is said to be differentiable function or continuous function if it is differentiable in the open interval or every number in its domain. So na-discuss natin, na-discuss po sa basic calculus yung mga naunang module ni Sir Romel, yung about continuity of functions. Ngayon, i-relate natin yung continuity of function sa differentiability of function. So it means that not all functions are differentiable in each domain. And recall na rin po natin kung paano natin malalaman if the function is continuous at a given number c. So meron po tayong tatlong conditions doon. Number 1, f of c is defined, meaning if we evaluate the function at c, yung sinasubstitute po natin yung value ng c dun sa function, kung x po yung independent variable, dun po natin sinasubstitute, dapat po may real number tayong makukuha to say that f of c is defined. Ngayon, if defined po ang f of c, we can proceed to the second condition that the limit of f of x as x approaches c exists. So malalaman naman natin kung nag-exist ang limit if the left hand and the right hand limits at x approaches c, syempre po, exists and equal. So pag nag-exist ang left at right hand limits and they are equal, we can say that the limit of f of x as x approaches c exists. And the third, pag nakuha natin yung first at second condition, sa third condition, dapat they are the same. So, pag nasatisfy po itong tatlong conditions, ibig sabihin, the function is continuous at a given number c. So, sinabi rin po doon, isa lang po dito ang hindi masatisfy, meaning, the function is discontinuous at a given number c. So, ito po yung sinasabi natin. Note that the three conditions must hold. Otherwise, the given function is discontinuous at the given value of c. Then sinabi din natin na lahat ng polynomial functions ay continuous at any number. So, idagdag ko na rin po dyan yung sa rational functions. Ang rational functions naman ay continuity din at any number. Maliban po doon sa mag-undefine yung rational function. Or in other words, a rational function is continuous at any point in its domain. So kung wala po sa domain yung value na yon, hindi po siya continuous doon. So ngayon, i-relate natin yung continuity sa differentiability. So the following are the conditions of a given function f if it is differentiable at a given number c. So mahalaga pong malaman kung differentiable ang isang function sa given number c. So paano po natin malalaman? Number one, f of x is continuous at c. Meaning, para maging differentiable siya, dapat continuous muna siya at c. Then pangalawa po, f prime of c, meaning the derivative at c, yung kinuha natin yung formula na limit of f of x minus f of c over x minus c as x approaches c exists. Okay? So dapat itong dalawa po na ito ay masatisfy para masabi nating differentiable ang isang function at a given number c. Or in other words, masasabi naman nating differentiable ang isang function kung makakakuha tayo ng derivative ng function na yon. So we have this remark. So kailangan na maintindihan natin to. Number one, if f is discontinuous at x equals c, then f is not differentiable at x equals c. So meaning automatic po na if f is discontinuous at c, hindi na siya agad differentiable sa c. Second, if f is continuous at c, it does not mean that f is differentiable at x equals c. So ibig sabihin, kung continuous siya sa c, hindi yan implication na differentiable na agad siya sa c. So itetest pa rin natin yung second condition na dapat yung limit of f of x minus f of c over x minus c as x approaches c ay mag-exist para masabi nating differentiable siya. And last, if f is not differentiable at c, it does not mean that f is not continuous at c. So, balikan po natin uli. Number one, pag discontinuous sa c, automatic, hindi siya differentiable sa c. Sa pangalawa, kung continuous naman siya sa c, hindi ibig sabihin na f is differentiable at c. At pangatlo, kung hindi naman siya differentiable sa c, it does not mean that f is not continuous at c. So medyo nakakalito yung mga wordings pero madali naman siyang maintindihan. Kasi itetest pa rin natin kung siya ay differentiable. Basta malinaw po doon, pag discontinuous, not differentiable. Pag continuous, meron pa tayong itetest para masabing differentiable siya. Okay po? Kung itanong, pwedeng i-comment, no? Masasagot po natin yan kapag nag-review tayo ng mga comments. So a function f can fail to be differentiable at a number c if one of the reasons is true. Number one, so masasabi daw po natin na hindi siya differentiable sa number c if one of these reasons ay totoo. One, if discontinuous siya sa c. So pag discontinuous, automatic, Hindi na siya differentiable. Second, the graph of the function f has a vertical tangent at x equals c. So pag ginraph down natin yung function, tapos dun sa point na yon sa x equals c, ay vertical line yung ating makukuwang tangent. Alam naman natin na ang slope ng vertical line ay undefined. So meaning, hindi rin siya differentiable doon. Kasi nirelate natin before na ang derivative is the slope of the tangent line of the curve at specific point. And number 3, the graph of the function f has a sharp turn or corner or cusp. So ano ibig sabihin nun? Meron tayong visualization dito. So pag ginraph natin yung function or the graph is given, makikita natin agad kung hindi siya differentiable. Sa figure 1, kita na agad sa C, discontinuous siya. So since discontinuous siya sa C, automatic hindi na siya agad differentiable. Sa figure 2, makikita natin sa C na ang tangent line na nabuo ay isang vertical line. Meaning, hindi na siya differentiable. At C, yung third, ito yung sinasabi natin yung kanina sa figure 3, no, na kapag may sharp turn, yung parang patusok yung graph natin doon sa C, yan. Yan po ay hindi differentiable. Okay po? So we have this example. Identify if the given function is differentiable at the given value of c using the 3 conditions. So yung 3 conditions naman yung, syempre, kailangan makita natin na continuous siya. So for example, we have f of x equals x to the 1/3. So this is our function. Then let x equal 0. Yung ating titignan na differentiable kaya itong function na to at x equals 0. So first, titignan natin if defined yung f of 0 kasi yung c natin is 0. So pag sinubstitute natin yung 0 dun sa x, magiging 0 to the 1/3. So makukuha natin is 0. So defined siya. So sa first condition, f of 0 is defined and is equal to 0. Second condition, kailangan makuha natin yung f prime of 0 na defined din. No? So sa f prime of 0, formula natin is the limit. Ito ginawa natin to last time. Limit of f of x minus f of 0 over x minus 0 as x approaches 0. Then, yung f of x, substitute natin yung x to the 1/3 dito. So, kaya naging x to the 1/3 minus yung 0 naman, substitute natin sa x, magiging 0 to the 1/3. So, 0 to the 1/3 is 0, kaya minus 0. Then, over x minus 0 is x as x approaches 0. Then, syempre, x to the 1/3 na lang yung matitira sa numerator. Then, by law of exponents, magiging limit of 1 over x to the 2/3 as x approaches 0. Then, alam naman natin na magwa 1 over 0 ito. So, meaning, the limit does not exist. So, pag hindi nag-exist yung limit, automatic din po na yon na hindi magpaparehas yung number 1 at number 2 na sagot natin. Sa number 1, defined at 0. Sa number 2, hindi nag-exist yung limit. So it means that, ito po yung graph ng ating f of x equals x to the 1/3. Yung kung mapapansin natin, at 0, vertical line yung tangent line. So meaning, the function f of x equals x to the 1/3 is not differentiable. Pero continuous siya at x equals 0. Pwede nyo po itong i-check sa yung tatlong conditions ng continuity of function. Continuous siya, but not differentiable at 0. The graph of this function does not have tangent line at the point where x equals 0. So kung nakita natin, tangent line nga, vertical line nga po yung nabuo. So we have another example. We let f of x equals the absolute value of x. And we let x equal 0. So tingnan din natin kung differentiable itong f of x if x equals 0. So again, the first condition, f of c is defined. Paano natin nalaman? Siyempre, yung c natin is 0. So f of 0, substitute natin yung 0, absolute value of 0 is 0. So it is defined. So sa ikalawang condition, we have f prime of 0 equals limit of f of x minus f of 0, kasi pag sinubstitute natin yung 0 doon, so magiging 0 naman din yung sagot, no? Over x minus 0 as x approaches 0. So, ayan na po. Yung f of x natin is absolute value of x. Then yung f of 0 natin is 0 over x as x approaches 0. Then, the limit is the limit of absolute value of x over x as x approaches 0. So, hindi naman tayo agad-agad magsasubstitute ng 0, no? Kasi de-define muna natin itong absolute value of x. Okay? So, alam naman natin na ang absolute value of x ay equal to positive x if x is greater than 0. Absolute value of x is equal to negative x if x is less than 0. So it will produce two values of limits. Okay? So una, yung if x is greater than 0, so magiging positive x ito, positive x, so magiging x over x, so limit of 1 as x approaches 0, so it is equal to 1. If x is greater than 0. Pag less than 0 naman, so itong absolute value of x is negative x. So negative x over x is negative 1. So the limit of negative 1 as x approaches 0 is negative 1. So makikita natin na magkaiba yung sagot sa greater than 0 at saka sa less than 0 sa absolute value. So ano yung ibig sabihin nun? So ibig sabihin nun, since hindi sila equal, f prime of 0 does not exist. Okay? So, pag hindi na-exist yung limit, yung f prime of 0, syempre, it involves limit, ibig sabihin po that the given function f is not differentiable at x equals 0. Okay? Pero kung aware naman na po tayo sa graph ng isang absolute value function, so sa graph ng isang absolute value function, so kung makikita natin, ito yung pa-v, at sa 0, sa x equals 0, ito po yun, sa origin, makikita po natin na pointed siya. So, di ba kanina, meron tayong condition doon na kapag pointed ang graph doon sa point na yon, ay hindi na siya agad differentiable. So, mas madali po, kung ma-identify natin agad yung graph, mas madaling malaman kung differentiable or not, given those conditions. Ayan. So, yung po, ang examples natin na para malaman natin kung differentiable or hindi at ano po ang relasyon ng differentiability sa continuity. Pero ang dalawang examples natin ang nagpapakita po ng hindi differentiable. Pero makikita naman din po natin sa mga iba pang examples yung mga continuous function na at the same time ay differentiable function din. Kaya meron po akong challenge sa inyo. So using those conditions, I want you to show this piecewise function f of x equals x squared plus 2x minus 3 over x minus 1 if x is not equal to 1, for if x is equal to 1, is both continuous and differentiable at x equals 1. So may pagkakataon na continuous siya at the same time differentiable. Kasi yung dalawang examples natin kanina ay continuous lang pero hindi differentiable. So since sa general mathematics ay na-discuss ninyo ang piecewise function at sa mga previous lesson din ng pre-calculus at basic calculus ay may piecewise function din. So I hope na masagutan natin ito sa mamaya po at sa ibang araw. At isend niyo po sa aking email mamaya, ibibigay po uli natin para makita po natin kung tama ang ating mga ginawa. Okay? So, try natin ito. May short quiz lang naman po. So, pero sasagutan din natin po agad. So, gusto ko po, sana po na mag-comment po tayo kung yung mga sagot natin sa ating mga items dito sa short quiz. Number 1, there are 3 conditions to determine if the given function f is continuous at the given number c. So, meron po bang 3 conditions para malaman kung continuous ang isang function at the given number c? A, true, or B, false. So habang naghihintay po ako ng inyong kasagutan, bati po muna tayo sa mga masugid na taga-subaybay natin. No? Kay Janelle Ande Guzman, maraming salamat. So good afternoon din. Ma'am Jennifer Obrero, ang assistant to the principal sa Buting Senior High School, maraming salamat po. Pelayo Baring Kanama, John Michael Malihana, Rosalie Sablay Galindo, maraming salamat. Good afternoon. Mefil Laurente, ng ALS SDO Pampanga, Candaba. Hello po sa inyo dyan, sa Candaba North District. Kay John Vincent, good afternoon. Kay Alfiter Mangelen, pa-shout out yan, na-shout out na kita. No? Rainier Nolasco Agustin, good afternoon. At ayan. So nagsagot po, ang karamihan po ng ating sagot ay A. So tama po, the answer is A, true. So number 2, if f is continuous at an open interval C, then it is differentiable. So kapag ba continuous ang function at on open interval C, automatic differentiable siya doon sa open interval. Is it true? Letter A is true or false for letter B? Ayan. So maraming salamat sa mga pagsagot. Luis Gia, Ayla Marie, Pastor Fide, mga students ko yan. Charlene Cascabel, thank you. Jocelyn Notario ng Jenica Boquiren ng Buting Senior High School. Miaka Jeline Abong, Rainier Nolasco Agustin. Hello po sa inyo dyan. Yan. So, A po ang sagot ng karamihan sa ating mga participants, no? So, tama pa. A, ayan si Al ay A. So, tama po ba na continuous, pag continuous, differentiable siya? Or the other way around? Pag differentiable, sabi natin kanina, pag differentiable ay continuous. Pero sinabi rin natin na hindi porket continuous siya, automatic differentiable. May tatlong conditions nga tayo sa graph, no? May tatlong examples tayo sa graph na continuous siya pero hindi differentiable. So, ayan, kinorek na po ang sagot. Thank you. So, ang correct answer dito is letter B, false. So, number 3, the given graph shows differentiability. O yan, may pointed. So, true or false? So, sa C ba? Sa C, point C, siya ay differentiable. Siyempre paulit-ulit tayo kanina. No? Alam naman natin na pag pointed doon sa point na yon, so hindi siya differentiability. So, the answer is false. Number 4, the polynomial function f of x. So, ito polynomial to. Differentiable ba siya at any number in its domain? A, true. B, false. Ito naman ay quadratic function. No? And, ayan. So, makalalaman naman natin kung differentiable siya. Kung kuha mo ng derivative. And sabi naman natin sa polynomial kanina. So, the answer here is letter A, true. So, number 5, if the limit of f of x as x approaches c is not equal to f of c of a function f, then the differentiability fails. Obvious naman po na siya ay magfe-fail ang differentiability for number 5. So maraming salamat po sa mga nagsagot po at meron pa naman tayo sa mga activities maya-maya. No? So kaya pa ba natin? Siyempre ang sagot natin ay siyempre kayang-kaya pa. No? So proceed tayo sa ating susunod na lesson about differentiation rules. Okay? So recall that determining the derivative of a simplest function using the limit definition can be a lengthy and tedious process. So masyadong mahaba kapag lagi nating ginagamit yung definition ng derivative sa pagkuha ng mga paano kung masyadong yung function mismo ay masyadong yung marami, halimbawa, yung mga naka-radical o kaya yung exponent niya ay masyadong malaki. So, pag ginamit natin yung definition, okay lang naman, pero masyadong mahaba. So, meron tayong rules, parang yung sa limit of a function. So, sa limit of a function ay nung umpisang lesson, ginamit yung definition ng limit sa pagkuha ng limit. Pero later on, merong rules sa pagkuha ng limit or the limit laws para mas mapadali yung ating pagkuha ng limit. So sa differentiability o sa derivative, meron din naman. So para mas mapadali yung pagkuha natin ng derivative ng functions, ay meron tayong rules na pwedeng gamitin. So ang tawag po dito ay differentiation rules or formulas. And in this lesson, we will focus on the algebraic functions. So ito ay polynomial, rational, and radical functions. Pero mamaya may example tayo ng exponential at logarithmic functions. So now, the first rule is the derivative of a constant function. The graph of a horizontal function is a horizontal line, or constant function, sorry. The graph of a constant function is a horizontal line and has a zero slope. The equation is represented by y equals c, or f of x equals c. Recall that the derivative measures the slope of the tangent line. So, the derivative of constant term is 0. Since ang slope niya is 0, the derivative is also 0. Example, if y is equal to 300,000, so this function is a constant function. So, the first derivative, pag ginawa natin ang derivative nito, since constant ito, automatic that y prime or the derivative of y is 0. So, lahat ng constant function, pag kinuha na natin ang derivative, 0 na agad yon. So, kahit hindi na natin gamitin yung definition ng derivative, since meron na tayong rules, pwede na natin agad-agad sabihin that the derivative of y is 0 because of the function given is a constant function. Second rule, derivative of a power function. So, ang sabi doon, a function of the form f of x equals x to the n. Or y equals x to the n, where n is a real number, is called a power function. In general, this is called power rule. So, pag may x, tapos may exponent n, where n is a real number, so gagamitin natin yung power rule sa pagkuha ng derivative. So, paano yon? If y equals x to the n, then the derivative of y is n. Yung exponent na n, so gagawin siyang constant multiple. So, magiging n times x, then the exponent is n minus 1. Meaning, babawasan natin ng isa yung exponent. Or sa madaling salita, ibababa natin yung n, magiging constant multiple, then babawasan natin yung isa ng isa yung exponent. So, it is n times x raised to n minus 1. We will apply this rule in differentiating polynomial, rational, and radical functions. So let's have this example. Sa polynomial functions muna tayo. So for example, we have y equals x at we want to get the derivative of y. Okay? So derivative of y prime. So since x ito, meron tayong exponent na 1 dito. Okay? So actually, this is an identity function. So actually, the derivative of an identity function is 1. Automatic yon, no? 1. Pero pag ginamit natin yung power rule, yung 1 na exponent, gagawin natin constant multiple. So 1 times x, then yung exponent niyang 1 ay babawasan natin ng isa. So magiging x to the 0 to. Alam naman natin na x to the 0, if x is not 0, ay 1. So 1 times 1 is 1. So the derivative of y equals x is 1. Okay, another example. If f of x equals x cubed, so pag kinuha natin yung derivative ng f of x, yung 3 na exponent, bababa natin. So magiging 3, then times x, then babawasan natin yung isa yung exponent. So magiging squared na lang to, no? So sa madaling salita, f prime of x is equal to 3 times x, 3 minus 1, or 3x squared. Okay? You can check this kung gagamit tayo ng definition, yung may limit of blah, blah, blah. No? So, makikuha din natin is 3x squared. Okay? Sana malinaw po ang paggamit ng power rule sa polynomial functions. Sa rational function naman, example, we have g of x equals 1 over x squared. So, paano natin magagamit ang power rule? So, una, eto naman, alam naman natin sa exponent rule, no? So, or sa exponent law, na kapag nasa ilalim tong x squared, pwede natin iakyat, no? At gagawin lang nating negative. So, we have g of x equals x to the negative 2. Okay? So, etong 1 over x squared ay nire-write natin sa pamamagitan nito, no? Naging x to the negative 2. Then, by power rule, negative 2 na yung exponent niya, ibababa natin bilang constant multiple. So, magiging negative 2, then x, then negative 2 minus 1. Okay? So, negative 2 yung exponent, binaba natin, naging constant multiple siya, negative 2. Then, x, negative 2 minus 1. So, lagi may minus 1 yon sa exponent. Or, negative 2x to the negative 3. Kasi negative 2 minus 1 is negative 3. No? And pwede natin i-rewrite ulit since x ito to the negative 3, pwede natin ilagay sa denominator para maging positive yung exponent. So, ang ating answer is negative 2 over x cubed or x raised to positive 3. So, naging positive na yun. Okay po, so yan po yung ilan sa mga examples ng paggamit ng power rule sa polynomial at sa rational functions. So sa radical functions naman, halimbawa we have y equals 4th root of x cubed. So para magamit natin yung power rule, i-rewrite natin to into the exponential form. So pag nilagay natin sa exponential form, ito ay magiging y equals x to the 3/4. So yung exponent niya na 3, so yan po yun. Then yung index doon sa radical, index is 4, yun yung magiging denominator ng exponent. By sa radical rule na pag nagre-write tayo into exponential form. So we have y equals x to the 3/4. Then syempre gagamitin natin yung power rule, ibababa natin yung 3/4 para maging constant multiple siya. So 3/4 times x. Then yung exponent 3/4, ma-minus natin ng 1. So we have 3/4 minus 1. So alam naman natin na 3/4 minus 1, syempre subtract natin yung exponent, 3/4 minus 1 is negative 1/4. So we have 3/4 times x to the negative 1/4. Then negative na naman po ang exponent ng x. So pwede natin gawin tong positive pero ibababa natin. So ang ating final answer ay 3 over 4x to the positive 1/4 na. So pwede na po ito. Or we can rewrite x to the 1/4 into radical form. So pwede ring 3 over 4 times 4th root of x. Okay? So ito po ang example ng paggamit ng power rule sa isang radical function. So, sa madaling salita, kapag radical at saka rational functions, ay mas maganda pong i-rewrite natin siya into exponential form. So sa radical, gagawing exponential form. Sa rational function naman, ay iaakit natin yung x na nasa denominator before we proceed to the power rule. Okay? So we have now, part kasi ng ating objective, yung exponential and logarithmic functions. So we have, in the previous study of the different function graphs, you have learned that exponential functions play an important role in modeling population growth and the decay of radioactive materials. So actually, isa sa mga applications ng exponential at saka logarithmic itong population growth and decay. At maraming problems yan, word problems yan sa mathematics. So titingnan natin kung paano natin magagamit ang derivative sa exponential and logarithmic functions. So logarithmic functions can help rescale large quantities and are particularly helpful for rewriting complicated expressions. So just as when we found the derivatives of algebraic functions, so yung algebraic functions, yun po yung kanina, yung polynomial function, rational function, and radical function. So now, we proceed to exponential and logarithmic function. So paano kaya natin gagawin yung derivatives ng exponential and logarithmic function? Siyempre, may rules din tayo dyan. So ito yung rules dun sa exponential function. So derivative of exponential function. So isa sa mga exponential function natin, yung e to the x. Yung e naman ay constant, no? F of x is equal to e to the x. So ang derivative niya ayon sa exponential function rule, no, sa differentiation, the f prime of x or the derivative is again e to the x. So meaning itong natatanging function na yung e to the x, na kapag kinuha yung derivative ay sarili pa rin niya. So the derivative of e to the x is the same, is itself e to the x pa rin. Okay? Second, the derivative of b to the x, where b is any real number. So kahit anong base ito. So itong e kasi constant to, no? may value yan na constant. Siyempre, irrational yun. Itong b ay kahit anong constant. Tapos merong exponent x. Okay? So, the derivative of b, where b is any constant, raised to x, is equal to b raised to x. Kopyahin po natin yung function, b raised to x, sorry. So, b raised to x, pero may multiplier na natural logarithm of b. So, b raised to x times ln of b. Kung ano man yung base na yon. Okay? So, let's have this example. Y equals e to the negative x. So, this is an exponential function. So, base sa rule natin, if we have y equals, balikan po natin, no, para so, y equals e to the negative x. So, negative po yung exponent. So, pwede natin i-rewrite to be 1 over e to the x. So, this is, ang ginawa natin ay we express with positive exponent. Okay? Then, gamitan natin ng quotient rule. Okay? So, sa quotient rule, kung familiar kayo sa acronym na low d high minus high d low over low squared. So, pwede natin gamitin yon. Or sa madaling salita, yung denominator, ito po yung e to the x, times derivative. Yung d po dito, hindi to variable. Ito ay derivative. Derivative of the numerator. So, we have e to the x times derivative of the numerator, which is 1, minus, kopyahin po yung numerator, which is 1, times derivative of the denominator, e to the x, all over square of the denominator. So, e to the x squared. So, ito po yung quotient rule. Ulitin po natin yung quotient rule. E to the x, the denominator, times the derivative of numerator, minus the numerator, times derivative of the denominator, over square of denominator. Ito po ay ginagamit kung meron tayong rational function na merong variable, let's say x, dun sa denominator. Okay. So, alam naman natin na yung derivative of 1, kanina may rule tayo, derivative of constant. Sabi natin, the derivative of constant is 0. So ito ay e to the x times 0. Minus 1 times derivative of e to the x. So sabi natin kanina, ito lang yung ito yung function ng e to the x, ng derivative niya ay sarili niya. So the derivative is e to the x over e to the x, then squared ulit. Then we simplify pa rin. We have, syempre, e to the x times 0 is 0 na to, no? 0 na yan. Then ito ay negative e to the x kasi negative 1 ito tas e to the x. So negative e to the x. Kaya ang numerator natin is negative e to the x. Then para mapakita lang natin na makakancel natin yung e to the x, kaya pinaghiwalay po dito. So e to the x times e to the x. So we cancel e to the x. So ang natira is negative 1 over e to the x. Okay? So this is now the derivative of the given function. So sa madaling salita, kung titingnan natin, ang given natin is e to the negative x. So the derivative of e to the negative x is negative 1 over e to the x. Ang ginamit natin ay the quotient rule. Okay? Sa logarithmic functions naman, actually po, kumuha lang po ako ng isang example kasi limited lang po yung time natin, 40 minutes lang po. Pero you can browse po yung mga modules natin ng iba't ibang divisions para marami pa tayong makitang mga examples about logarithmic function and exponential function. So sa logarithmic function naman, if f of x equals logarithm of x with base b, okay, then the derivative f prime of x is 1 over, tingnan natin magiging, no? So the function is logarithm or log of x with base b. So makikita natin, naging fraction siya sa derivative. Maging 1, parang ni-reciprocal, no? Parang ni-reciprocal. So naging 1 over, then kung ano yung function dito, let's say x, kasi x yung nasa natin. So yun yung x na yon. Then, naging natural logarithm ln. Then, kung ano yung base yun po yung kinukuhanan ng natural logarithm. Okay? So 1 over x ln of b. So meron tayo ito, yung natural logarithm naman, if we have ln x, f of x equals ln x, the derivative ay madali lang. The derivative is 1 over x. Okay? So as simple as that. So ito ay pwedeng i-derive, pwedeng i-prove natin ito using the definition of derivative. Kaso mahaba-haba rin yun. Kaya pwede nyo i-search po yung paano ito na-derive. So let's have this example. G of x equals x squared plus negative 2 ln x. So itong x squared, malinaw na to na ito ay power rule. No? So yung x squared, so at first we clear off parentheses kasi kahit wala naman tong parentheses dahil wala naman tayong mababiolate dyan. No? So yung plus negative, so gagawin lang natin negative 2 ln x para mas simpleng tignan. Then, yung x squared by power rule is, sabi natin, ibababa natin yung 2, magiging constant multiple, tapos babawasan natin ng isa, yung exponent. So, naging 2x, kasi raised to 1 yun. So, 2x. Minus, ito naman, ayon sa ating derivative ng natural log, kanina po. So, this is 2, the constant multiple. Yung ln x naman ay 1 over x, the derivative. So, we have 2x minus 2 times 1 over x. Okay? Then, we simplify na. We combine similar terms. So, or we perform operations. So, yung negative 2 times 1 over x is negative 2 over x. Then, 2x minus 2 over x, siyempre, subtraction of fraction naman ito. So, we use yung mga rules no tungkol sa operations of fractions. Ayan. So, we have 2x squared. So, kung kukuha na natin ng LCD ito, which is x, so we have 2x squared minus 2. Okay? So this is now our derivative of the given function g of x. Okay? So since ayan na, time na naman. So actually nakakabitin yung pag-aaral natin no? Kasi hanggang 40 minutes lang tayo. Pero at least nakikita natin yung mga dapat nating matutunan ng mga competencies. Ngayon, ito yung magiging paraan at dahilan, mag-umpisa tayo para maalamin sa iba't ibang resources yung mga iba't iba pang mga examples dito sa derivative or differentiation rules. So, ito yung mga activities na sana ay masubukan po ninyong gawin. Then, you can contact me kung bigla po kayong nahirapan bigla no, sa pagsasagot. You can contact me through my email. Pwede rin na naman sa Facebook account. Search nyo lang po yung aking pangalan. Makikita nyo naman po agad doon. No? So, we have these first activities. I-apply lang natin yung differentiation rules. So, halimbawa, number 1, yung about power rule, pero i-rewrite muna natin kasi ito ay rational. No? Sa number 2, ito naman ay rational tsaka radical. No? So, i-rewrite din natin to para magamit yung power rule. So, ito naman, may constant multiple na 2 at may power na 3. Okay? So, i-perform muna gagamitin muna natin yung law of exponents, then magpa-power rule. Then, itong number 4 ay rational function, no? Pero i-rewrite muna natin kasi x yung nandito, dapat y muna. So, i-rewrite natin to be y equals para makuha natin is dy dx. Okay. Then, for activity 2, so ito naman, derivative of a function at a number. So, yung kanina nating lesson. So, find the indicated derivative. So, ito yung given function. Kukunin natin yung derivative at negative 1. So, ito yung pangalawa. Kukunin natin yung ito, ginawa natin ito nung nakaraang Friday. Kung natatandaan nyo po. Pero ang ginamit natin ay definition of derivative na ang haba-haba. So ngayon naman, tatry natin i-check yung ating ginawa last Friday, pero ang gagamitin natin ay differentiation rules para ma-compare natin kung ano yung mas madali para sa atin sa pagkuha ng derivative. So we have number 1, number 2, and number 3. So ito po yung ating ginamit na references. So, tara, gawin natin. Nahihirapan man, itutulay natin. Siyempre, dapat panoorin itong ETUlay. So, thank you and see you every Friday. Yung ating mga outputs, you can send that to my email at erwin.lugtu@deped.gov.ph. Hindi ko nasulat dito yung messenger, Facebook messenger ko, pero pwede nyo rin akong i-PM through messenger, Facebook messenger at Erwin Lugtu. So, ayan na. Maraming salamat po kay Mama Ami ng Buting, Pelayo Baring Kanama, good afternoon. At sa mga students, lalo-lalo na sa ating mga students and teachers sa buong bansa at sa kung meron po tayong viewers sa ibang bansa. So maraming salamat po. At gawin po nating hobby ang panonood ng ETUlay para sa karagdagang kaalaman ng ating mga mag-aaral at mga guro. So again, magkita-kita po tayo uli sa susunod na Biyernes para sa ika-6 na linggo na ng Basic Calculus. So again, maraming salamat at paalam po ngayong hapon.
Sigurado ako na marami ka na namang natutuhan sa ating ETUlay tutorial session ngayong araw. Tandaan, ito ay hindi lamang para sa ating mga mag-aaral, kundi pati rin sa ating mga minamahal na guro at mga magulang na kaagapay natin para maituloy ang pagkatuto sa kabila ng nararanasang pandemya. Patuloy ding sumubaybay sa DepEd TV para sa mga araling ginawang video episodes. Mapapanood ito mula Lunes hanggang Sabado, alas 7 ng umaga hanggang alas 7 ng gabi sa inyong mga telebisyon. Abangan sa Lunes mula 1:00 ng tanghali ang iba pang aralin sa ating ETUlay free online tutorial session sa Science. I-like and subscribe at manatiling nakasubaybay sa ating ETUlay tutorial session sa DepEd Edtech Unit FB page at Educational Technology Unit channel sa YouTube at sa DepEd Tayo at DepEd Philippines social media accounts. Paalam!